does the flap of a butterfly wings in Brazil set off a tornado in Texas? This infamous phrase comes straight from the title of a paper published by Edward Lorenz in 1972 and has definitely become the definition of the butterfly effect. Surprise! Butt sex! Set of differential equations. Surprise. And in particular, those three, which are also proposed by the same Edward Lorenz. We can of course plug some numbers into the equations, and it quickly becomes apparent that two sets of initial parameters quickly diverge, or in other words, chaos emerges. While I do certainly like the chaos, numbers can be a little dull at times to say the least. So what can we do about it? You see, in each set of initial parameters there are three numbers, and what else has three components, class? Yes, that's right. A point in 3D space. Because we're tackling 3D stuff, I thought this is the perfect opportunity to torture myself for the amusement of my audience, that's you, by using Blender for a task that could have taken 3 minutes in any of those software. So let's begin, shall we? Open Blender and select the default cube, but instead of the usual annihilation, obliterate it. And now, head directly to the scripting tab. Now define some intuitively named variables, and then create a Lorenz function that executes the Lorenz equations. Then using this function, in a loop, create some points and some edges in between. And now comes the fun part, because to turn this data that you have present to a Blender object, you have to write some mandatory lines of code, and my advice is not to bother and just to copy them from the screen right now. Oh, what? You missed it? Well, that sucks, I guess. So execute the code, and now we have a Lorenz attractor. Apply a skin modifier, then select any of the continuous edges and make a scene. Then select all the edges, press U and unwrap. And your UV map should look something like this. I'm out of breath. Now we're actually entering null territory, so don't mind me. Get the Y value of the UV coordinates, plug it into a compare node and plug that to the surface, and you're going to get a white segment in the middle of a black line. Now, we can use this as a factor in a mixed shader between a transparent BSDF and a principled one, and if we set our material from opaque to anything else, we're going to get just a segment of a line and nothing else. For the last part, which is the animation, you're going to need two nodes, a driver based on frames, and an add node. Then you play the animation, play with the parameters, play some piano, play some Minecraft, and I don't know, play with yourself. Thank you for watching. Now it's time I leave it to the Lorenz Attractor.